Okay, so back to F equals ma. So when you're using F equals ma, remember, this is really important, that F, running out of room, but this here is the resultant force. So that's key to using F equals ma. I think we're doing physics. I think Paul writes that like that, and you're welcome to do that. I think in a way that's quite a good reminder that you need to add together your forces. So we have a box of mass 8 kilograms lying on a smooth horizontal floor. A force of 10 newtons is applied at an angle of 30 degrees, causing the box to accelerate along the floor. So it's going to accelerate along the floor. So when you're deciding which way to resolve your forces, you want to be resolving in the direction of motion and make that your positive direction. And that just makes mechanics so much easier. And then I also need a perpendicular direction, and I'm going to take up as being positive. It's kind of what you'd expect to do, really. Right, forces acting on this box. So we have the weight acting down. So I've got 8G acting down. And we've got a normal reaction acting up. Again, I think physics, you call that a normal contact force. I'm really happy for you to carry on doing that. You would see it just called R in maths questions for reaction. In this case, R will not equal 8G because you've got a component of this force here which is acting upwards. So R is going to be a bit less than 8G. There's going to be a little bit less reaction if there's a little bit of a tug upwards on that box. So first of all, we're going to find the acceleration. Oh, the other thing I was going to say is this force of 10 newtons, that's actually acting as tension on that box. So if it's being pulled along by a string, it's tension in the string. If you wanted to actually draw that as a force, it'd be a tension force. Right, acceleration. So acceleration is in the direction of motion, so accelerating that way. You can just do like a little double arrow to show that if you want to. So I want to resolve forces horizontally to find the acceleration. And I need the resultant force. Nice and easy for this one because it's sliding along a smooth floor. The only force acting in the direction of motion is 10 cos 30. So it's just a component of this force acting parallel to the floor. So 10 cos 30 is equal to the mass times the acceleration, and then if you pop that through a calculator, the acceleration comes out as 5√3/8, which seems far too exact for a mechanics question, but that's what I've got written down, so I'm just going to go with it. Meters per second squared. And then the next thing we want to do is find this resultant force. So we want to find the normal reaction. Did I call that resultant force? I meant reaction force. Right, we want to find this reaction force, so find the normal reaction. So I'm going to resolve vertically. And so acting in a positive direction, upwards, I've got R plus 10 sine 30. So that's that little bit of this force that's acting that way. And then there's no movement vertically, so these forces are in equilibrium. And so anything acting upwards, the total of that will have to equal the total of all things acting downwards, or you can add them to get 0 if you prefer to think of it that way. And so this is equal to 8g, or you could write that as minus 8g equals 0, as this is acting in a negative direction. And then it really is just a question of putting that through a calculator. So r is equal to 78.4 minus 5, and then because we've used acceleration due to gravity, it makes sense to go to 2 sig fig. You probably wouldn't get penalised for 3 sig fig, but any more than that you will lose your answer mark in mechanics, but only in mechanics, so don't start rounding too heavily in the rest of your maths. So I hope that's all right. If that's not okay, just give me a shout. And when we bring in friction, we'll start making these F equals MA questions. There'll be a little bit more going on with those.